This is SpaceTime Series 28, Episode 19, for broadcast on the 12th of February 2025. Coming up on SpaceTime, a new study looking at when water arrived on Earth, what Searles Lakes and the asteroid Bennu have in common, and a new study suggests that meteoroid impacts may have a bigger role in triggering Marsquakes than previously thought. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has concluded that water didn't arrive as early during Earth's formation as previously thought. The findings, reported in the journal Geochemistry and Cosmochemistry, could provide new insights into when life first originated on planet Earth. The new study supports the idea that water arrived towards the final stages of Earth's development into a planet from dust and gas, what geologists refer to as late accretion. See, the scientists are trying to learn when the constituent materials necessary for life first appeared on the planet, so they can understand how and when life actually began. Now, according to the present scientific understanding, at least 3 necessary ingredients are essential to kickstart life. These are water, energy, and a soup of organic chemicals, including hydrogen, nitrogen, oxygen, phosphorus, and sulfur. The study's lead author, Catherine Birmingham from Rutgers School of Arts and Sciences, says when water was delivered to planet Earth remains a major unanswered question in planetary science. Many believe Earth's water condensed out of the protoplanetary disk from which the planet was first formed. Others, however, say conditions in the inner solar system would have been too hot, and even worse, when Theia, a Mars-sized planet, slammed into the proto-Earth 4.5 billion years ago to create the current Earth-Moon system we have today. Therefore, the water must have arrived later. Now, if science knows the answer to this riddle, researchers will be able to better constrain when and how life developed. Using thermal ionization mass spectrometry and a new analytical method, Birmingham colleagues studied isotopes of the element molybdenum. An isotope is a form of an element with the same number of protons but different numbers of neutrons. This allows it to share the same basic chemical properties while having a different atomic mass. The molybdenum isotopic composition of Earth rocks provides a window into events occurring around the time of Earth's final core formation, when the last 10 to 20% of material was being assembled by the planet. Birmingham says this period is thought to coincide with the Moon's formation. The authors extracted molybdenum from meteorite samples. Meteorites are generally divided into 2 groups. The first, with constituent elements suggesting the meteorites formed in the outer solar system, presumably a colder, wetter area, and the second group with characteristics indicating its meteorites formed in the inner, presumably drier, hotter part of the solar system. The authors compared the molybdenum isotopic composition of these meteorites to Earth rocks from Greenland, South Africa, Canada, the United States, and Japan. The molybdenum in these rocks is generally considered to have been added to Earth during the time of the Moon's formation, which is when the final core formation also occurred. Once they gathered their different samples and measured their isotopic compositions, they compared the meteorite signatures with Earth rock signatures. The analysis showed that the Earth rocks were far more similar to meteorites sourced from the inner solar system than those sourced from the outer solar system. The data supports the interpretation that water was delivered to the Earth in smaller portions after the Moon was formed and far later during the Earth's formation. This is SpaceTime. Still to come, what does Searles Lake in the Mojave Desert and the asteroid Bennu have in common, and how meteoroid impacts may have played a bigger role in triggering Marsquakes than previously thought. All that and more still to come on SpaceTime. For decades, geologists and rockhounds have gathered each year at Searles Lake in the Mojave Desert of southeastern California. Wielding crowbars and pickaxes, they hunt for showy deposits of minerals such as halite, trona, calcite, and dolomite. Now, planetary scientists from NASA and several other institutions are finding many of the same water-soluble minerals, though their tools and destinations are worlds apart. Back in September 2016, NASA launched a van-sized spacecraft called Osiris Rex, which travelled billions of kilometres to reach a small diamond-shaped asteroid called Bennu. Scientists think that this rubble pile asteroid, which crosses Earth's orbit every 6 years, formed from fragments of a larger asteroid that broke apart between 1 and 2 billion years ago following a cataclysmic collision. In October 2020, Osiris Rex briefly touched down on a Bennu's surface, collecting 4.3 ounces of crumbly regolith, which it then stowed away before returning to Earth. This report from NASA TV.
One of Earth's closest neighbors is a dark, jumbled mass of rocks and boulders known as Asteroid Bennu. Bennu is ancient, a rugged survivor of the solar system's chaotic past that may hold clues to the origins of life. In October 2020, a NASA spacecraft called Osiris Rex touched down on Bennu and collected a sample for return to Earth. Scientists had expected that this touch-and-go event, or TAG, would have little impact on the asteroid. After a slow descent, the sampler head would briefly make contact, inject a puff of gas, and capture a handful of material. Perhaps it would also leave a small divot at the sample site, a subtle footprint in the soil, or so it was thought. When images of the TAG event beamed back to Earth, they were far more dramatic than anticipated. Despite its slow touchdown, Osiris Rex had punched through the surface and set off an explosion of loose material. Tons of rocks and pebbles were ejected, radiating outward in a wall of debris. The pictures were stunning, but why did Bennu's surface behave so unexpectedly? The answer involves cohesion, an attractive force that can bind molecules together. Cohesion gives water its surface tension and keeps droplets together even in a microgravity environment like the International Space Station. Granular materials like wheat flour, cocoa, and dust can also exhibit cohesion, which pulls individual grains into clumps. On Bennu, scientists had expected cohesion to act like a bit of glue between the rocks, making its loose surface more solid. But the TAG event showed that Bennu's uppermost layers are nearly cohesionless, deforming under stress like a fluid. A good analogy is a ball pit. Although the plastic balls are solid, they easily slide past one another and past boisterous children, behaving in mass like a fluid. Thanks to Osiris Rex, we now know that Bennu's surface is not held together by cohesion, but by gravity, or microgravity, with a minute tug less than 100,000th the pull of Earth. On the Moon, gravity is 16% as strong as it is on Earth, and more than 16,000 times stronger than it is on Bennu. As a result, loose material in the lunar subsurface is packed together more tightly, making the Moon's surface relatively firm. If a 50-kilogram mass of solid iron were to hit the Moon at the same speed as the TAG event, it would sink into the ground by only half a centimeter. Repeating this experiment at Bennu would yield a dramatically different result. Though the mass would strike with the same force, it would plunge 17 centimeters before stopping, over 30 times deeper than at the Moon. Bennu has consistently defied scientists' expectations, as each new finding reveals another facet of this small but surprising world. Using data from Osiris Rex, we now have the ability to look back and accurately recreate 30 seconds on asteroid Bennu. On October 20th, 2020, Osiris Rex made its final descent to a sample site called Nightingale. With its TAG-SAM arm outstretched, it approached the surface at 10 centimeters per second, the walking pace of an insect. 1 second after contact, it released a canister of pressurized nitrogen, detonating an explosion of particles and driving material into the TAG-SAM head for sample collection. 6 seconds after contact, while it was still sinking into Bennu, Osiris Rex fired its thrusters to begin the back-away maneuver. The engine burn lasted for 24 seconds, continuously pushing against the spacecraft and rapidly slowing its descent. Flying debris from the thrusters and the gas release pelted the science instruments, clogging them with dust. 9 seconds after contact, when Osiris Rex had sunk nearly half a meter into Bennu, it reversed course and began to rise. At 16 seconds, the TAG-SAM head re-emerged from the subsurface as the spacecraft continued to accelerate. 30 seconds after contact, Osiris Rex shut off its thrusters and drifted away with its sample of Bennu. Almost 6 months later, on April 7, 2021, the spacecraft returned for one last flyover to observe its footprint. At the point of impact was a new crater, averaging 8 meters across and reaching 68 centimeters in depth. Thruster marks overlapped with this tagged crater in an X pattern, increasing its volume by as much as 40%. A ridge of ejected material that had been kicked up during sample collection and then fallen back to the surface circled the crater like a campfire ring. With a puff of gas and an engine burn, Osiris Rex had displaced 12 cubic meters of granular material, 6 tons of loose rock that may have been packed together as lightly as a bowl of popcorn. After a final departure maneuver in May 2021, Osiris Rex began a 2-year journey back to Earth. Stowed on board were about 250 grams of asteroid Bennu, a bounty of scientific treasure destined for future discoveries.
In September 2023, Osiris Rex released a mini-fridge-sized re-entry capsule which parachuted back to Earth, landing in the Utah desert with its precious samples. Since then, scientists have been running these dark, powdery samples through a gauntlet of microscopes, mass spectrometers and CT scanners. Their findings, described in reports in the journals Nature and Nature Astronomy, reveal evidence of sodium and carbonate-rich salts known as evaporites. These minerals likely formed when a briny liquid gradually evaporated in the subsurface of a wet, muddy protoplanet about 4.5 billion years ago, during the very early days of the solar system. The thing is, there are very few places on Earth that produce combinations of evaporites similar to those found in the Bennu samples. One of the study's lead authors, Tim McCoy from the Smithsonian National Museum of Natural History, says one of the few places that does produce combinations of evaporites similar to those found on Bennu is Searles Lake. Although the minerals discovered on Bennu predate those at Searles Lake, they both formed in similar salty wet conditions. Soda lakes, like Searles Lake, intrigue planetary geologists, in part because they contain highly alkaline waters. With a mixture of sodium, carbonate and chloride ions, their brines are rich in phosphates, a substance key to the development of organic molecules, including some involved in the formation of genetic material, cell membranes, and other components thought to be critical to the formation of life. As we reported last week, scientists have announced the discovery of organic molecules, including several that are among the ingredients needed for life, in the Bennu samples. Water is a remarkably good solvent, meaning common salts like sodium chloride or calcium carbonate dissolve easily in it. At a molecular level, salts break into positive and negatively charged ions, such as sodium, chloride and calcium, and they're surrounded by molecules of water when they dissolve. The opposite occurs when water is removed from brines rich in ions, leaving the ions to bond and crystallize into salts. At Searles Lake, minerals typically develop in a predictable sequence of zones sort of like rings around a bathtub, with calcium carbonate and magnesium carbonate forming first, followed by calcium sulfate and sodium carbonate in the middle ring. That leaves the most concentrated brine deposits, chlorides and fluorides of sodium and potassium, at the centre of the lake. Minerals can also precipitate directly from fluids without evaporation if the ion concentration is high enough, as probably happened early in the sequence. McCoy believes precipitation occurred in both ways on Bennu's parent body. Researchers identified 11 minerals in the asteroid samples that likely formed in liquid water, and 6 of these, trona, halite, personite, vanadite, calcite and domolite, are also found in Searles Lake. This report from NASA TV.
The origin of life is one of the deepest mysteries in science, but the clues to solving it have been buried by plate tectonics, the water cycle, and even life itself. For answers, scientists are looking beyond Earth to primitive asteroids like Bennu, the target of NASA's daring Osiris Rex sample return mission. Now, material from Bennu is revealing a lost world from the dawn of the solar system, with the right conditions to foster the building blocks of life. When scientists examined the Bennu samples, they discovered evidence of a wet and salty past. Among the dark rocks were bright veins of salts that form on Earth when brines evaporate from alkaline lakes. Scientists found microcrystals of trona and other evaporite minerals within the Bennu samples, indicating that they once held pockets of sodium-rich water. Such brines are ideal for cooking up organic molecules, carbon-based compounds that are the stuff of life. Bennu is a carbon-rich asteroid, and its samples are chock full of organics, including amino acids and nucleobases. Amino acids can be bonded together in long chains to build proteins, which give cells their structure and function. Life is constructed from a set of 20 amino acids, 14 of which were identified within the Bennu samples. Nucleobases are the genetic components of DNA and RNA. All 5 nucleobases were discovered in the Bennu samples, a first for extraterrestrial material collected by a spacecraft. In addition to organic molecules, scientists found that the Bennu samples are surprisingly rich in ammonia. On Earth, ammonia is a common agricultural fertilizer. It readily evaporates at room temperature, but is more stable in cold environments, like those found in the outer solar system. Bennu is too close to the Sun to retain pure ammonia, so its samples must have formed during a more distant, frigid past. Salts, organics, ammonia. Thanks to Osiris Rex, we can now piece together these clues to tell a likely origin story for asteroid Bennu. 4.5 billion years ago, in the nascent solar system's outer reaches, a world of rock, metal, and ice took shape. Radioactive decay heated its interior, melting some of the ice. Pockets of mineral-rich water reacted with formaldehyde and ammonia to produce organics. As the water dried up, the dissolved minerals crystallized, leaving bright veins within the rocks. The world migrated closer to the Sun until it was shattered in a collision and destroyed. Bennu accreted from the rubble and drifted further inward, eventually settling into a near-Earth orbit where it could be reached by Osiris Rex. Our planet was bombarded by asteroids like Bennu early in its history, suggesting that many of the same organic molecules were present on Earth before the dawn of life. These findings help to close a gap in our understanding of the early solar system, but key questions remain open. Many amino acids can be created in 2 mirror image versions, like a pair of left and right hands. Life on Earth almost exclusively produces the left-handed variety, while the Bennu samples contain an equal mixture of both. This means that on early Earth, amino acids may have started out in an equal mixture as well. The reason that life turned left instead of right remains a mystery. Additional insights may come in 2030 when NASA's Europa Clipper mission arrives at Jupiter. It will hunt for evidence of a briny ocean within the moon Europa, an environment favorable to producing organics. Until then, scientists will dig deeper into the Bennu samples, unearthing more molecular clues about the origins of life.
This is SpaceTime. Still to come, a new study implies that impacts by micrometeorites probably played a bigger role in triggering Marsquakes than previously thought. And later in the science report, researchers have finally discovered the best way to boil an egg. All that and more still to come on SpaceTime. A new study suggests that meteoroid impacts on Mars create seismic waves which cause the red planet to shake more strongly and deeply than previously thought. The findings, reported in the journal Geophysical Research Letters, are based on a new analysis of data from NASA's Mars InSight lander, which operated on the red planet between December 2018 and December 2022. The new investigation was carried out using artificial intelligence and machine learning. Similarities were found between numerous meteoroid impacts on the surface of Mars and Marsquakes recorded by InSight, opening up a new perspective on the impact rate and seismic dynamics of the red planet. By studying meteoroid impact craters, important properties of a planet and its surface can be determined. Satellite images help to constrain the formation time of impact craters, and this provides valuable information on impact rates. A new study by Valentine Bickel from the University of Bern has developed a comprehensive catalogue of impacts on the Martian surface that took place near the InSight lander during its mission. Tens of thousands of satellite images were searched through for new craters that would have formed during the time of the seismic monitoring by InSight. Craters were classified according to their size and their distribution, and this was then compared to the seismic recordings. Bickel and colleagues identified 123 previously unknown impact events. Now, based on their determined formation time, estimated magnitude and distance from the InSight lander, the researchers found potential matches between 49 seismic events and one or more possible impact events. Bickles says the data clearly shows that more impacts occur on Mars than were determined in previous studies using orbital images. In fact, the estimated impact rate is around 1.6 to 2.5 times higher than previously assumed. It means that some recorded Marsquakes are actually caused by meteoroid impacts, not tectonic activity. This has far-reaching implications for estimates of the frequency of Marsquakes and also science's understanding the dynamics of the Martian surface in general. In a companion study, the researchers focused on one of the newly discovered events, a 21.5 metre wide impact crater in the Cerebus Fossae region, which the authors were able to link to a specific high-frequency Marsquake. The Cerebus Fossae rift system is located in a young volcanic plain on Mars that's known for its tectonic activity. This discovery enabled the first direct comparison between an impact-induced seismic signal and a signal caused by internal tectonic movements. The authors compared the impact location and the time at which InSight registered the respective Marsquake. They were able to show that some of the seismic waves propagated through the deeper Martian mantle and not as previously assumed only through the surface crust. The new findings challenge previous assumptions about the propagation of seismic waves and suggest that numerous recorded Marsquakes were actually further away from the InSight lander than previously thought. In addition to relocating the epicenters of a range of quakes, this also means that the internal structural model of Mars needs to be revised. This is SpaceTime. And time now for another brief look at some of the other stories making news in science this week with the Science Report. A new study has found that men's average height and weight has increased by more than double the rate of women over the last 120 years as improved living conditions have curbed diseases. But the findings reported in the journal Biology Letters show that the key factor wasn't just improved living conditions, but the fact that women actually prefer men who are both sexy and formidable, resulting in these males fathering more kids than their smaller, less formidable rivals. The authors looked at the World Health Organization's data on changes in height and weight of 135,000 people from 62 countries as the disease burden decreased over the past 120 years, as well as adult height data from Wikipedia and a previous UK study. However, scientists also found that being sexy and formidable comes with a hidden cost of being more vulnerable to disease, which is why improved living conditions have made being big and muscly a safer bet than it once was. The research suggests that the differences in height and weight between men and women widen as disease burden decreases. A fossilised skull discovered in Antarctica has been revealed to belong to one of the oldest known modern birds, an ancient relative of ducks and geese which lived during the time of the dinosaurs. The near-complete skull belongs to a bird called Vigavus iai, which lived in Antarctica around 68 million years ago, which is about the same time as T. Rex was walking the Earth. Other Vigavus fossils were recorded 20 years ago, but there's been some doubt as to whether it was a modern bird. A report in the journal Nature claims this new specimen has something previous fossils lacked, a nearly complete skull. The new skull has helped lay that skepticism to rest, as it has several traits such as the shape of the brain and the beak bones that are consistent with modern birds, especially waterfowl. Scientists have finally discovered the best way to boil an egg. Researchers were able to develop a new method for the optimal boiling of eggs that perfectly cooks both the white and the yolk by using both computational simulations and real-world testing. A report in the journal Communications Engineering claims that alternating the egg between a pan of boiling water kept at 100 degrees Celsius and a bowl kept at 30 degrees Celsius every 2 minutes for 32 minutes yielded evenly cooked whites and yolks with a higher nutritional content than conventional boiling. The Australian government has banned the Chinese AI app DeepSeek from all federal government computers, tablets, laptops and cell phones on the grounds of national security. DeepSeek's a free AI-powered chatbot that provides an alternative to ChatGPT and Grok. The government says while the ban doesn't stop everyday users from downloading the technology, people need to educate themselves about its privacy and security risks and how it scoops up all your personal details. DeepSeek's AI model and apps have already been banned by a growing number of countries and government bodies concerned about its ethics, privacy and security practices. This latest move follows similar bans by Canberra applied to TikTok and Huawei, also on the grounds of national security. And while Beijing's priority seems to be scooping up all your personal information with its new AI, US President Donald Trump has announced a $500 billion project to develop an AI to try and cure cancer. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Clearly, Trump wants the US to be the world's leader in AI. He wants to be ahead of China, ahead of Russia, ahead of Europe, ahead of North Korea, ahead of all these different countries that all are wanting to use AI in different ways. And these companies would have built their AI data centers in different countries, and I'm sure they still are. I mean, he wants the primary AI computers and the most advanced technologies to be built in the US. And so this will be fascinating to see it unfold. It's just been effectively announced. Already the ground has been turned, the buildings in construction, and these are huge buildings that are going to be state-of-the-art data centers. There was NVIDIA, there was Oracle, there was Sam Altman from OpenAI's ChatGPT. They were all there, and SoftBank as well, the big Japanese company that invests a lot of money, and they're putting in $500 billion US. Now, clearly not all of that money is available yet. In fact, Elon Musk was saying that SoftBank only has $10 billion US, according to him, on good authority, and of course he's having lots of fights with Sam Altman from OpenAI about who's got the best AI.
Yeah, they don't get on, do they, those two?
No, well, Elon Musk was one of the founders of OpenAI, and he was funding it. And then when nothing much was really happening, he wanted to take control, and Sam Altman didn't want that, and Elon Musk decided to stop funding it. And that's when Sam Altman had to go to Microsoft and get tens of billions of dollars from them. And that began the change from an open source company into a closed source for-profit company. So there's been a lot of tension between those two, but construction hasn't finished yet. I mean, they're going to need to upgrade it on a regular basis to make sure that it stays state-of-the-art. But given NVIDIA is one of the partners, I mean, there's a great incentive to make sure that the US is leading the way with AI, because there's going to be great competition from other countries who are going to want to try and beat the US to the AI top of the totem pole.
One of the big problems with Altman is that he's looking at AGI. Tell me about that.
Well, that's artificial general intelligence. And there's even ASI, which is like artificial super intelligence.
Now, we're talking about Skynet here, aren't we?
Yeah, we're talking about the ability for computers to be much smarter than humans, to almost view us like as a pet, because they're just so damn smart. And clearly there's a lot of concern that these super intelligences, if they do indeed emerge in the next few years as is widely predicted, will make sure that they don't want to get rid of humans, they don't want to terminate us like Skynet did. And Elon Musk, for example, is very strong on wanting Grok to understand that humans are a very important part of the universe, that we should not be destroyed, that we created the AIs. I mean, it should look to us as its creator, and it should be our partner and our friend, not our master and treating us as pets. So we're definitely getting into the realms of science fiction. It's been written about for 100 years, ever since the Frankenstein days of the life which was part man, part machine. So it's not a new story. It's been written about and predicted for decades, and now we live in a time frame, in an era where we're actually making these machines that can actually reason and be intelligent. And whenever I show somebody ChatGPT, they are amazed how good the voice is, how natural and flowing the conversation is, and how different it has been with the modern AI systems to using Google Assistant, Siri, or Amazon Alexa over the past decade.
Well, that's got to raise the question, are they sentient yet?
Well, look, certainly it's possible for them to look like they're sentient. I mean, 6 months before ChatGPT emerged onto the scene, a Google researcher was having conversations with the AI system that it had. And if you read the transcripts, I mean, it does look like the AI is a little kid and is concerned for its existence, and it's very much alive and it's scared. But at the time, and this was before ChatGPT emerged, they were saying, look, of course it's going to say those things because it's been programmed to sound extremely human, but there's no actual intelligence behind all of this. It's sort of just a very clever bit of programming. But
that was years ago now, but
well, that was back in 2022, about 6 months before ChatGPT. So we've had the ability to have sentient appearing computer programs. Will it actually become sentient? I mean, will it need a lightning bolt like Johnny 5 is alive, number 5 is alive? What is the leap that's going to actually make it truly come alive? Well, we're still not there yet. I mean, there's been plenty of rumors that Sam Altman has cracked the code and he's got this bubbling away in the labs and it exists now. Other people are saying it's going to take a few years yet. But it would appear that, given the advancements in the AI chips and how they keep jumping in capabilities every year, like Moore's law with the computer processors in phones and tablets and computers, that this day will come and then humans will have created a new life form. And what's going to happen then? Well, that's why there's been so much emphasis on safety with AI. I mean, Geoffrey Hinton, the godfather of AI, has warned extensively. He quit Google over this because he was afraid that Google and other companies like OpenAI are not taking this seriously. And in fact, one of the founders of OpenAI left to go join Anthropic to specifically head up superintelligence safety. So there's a lot of people very concerned about it. But until it actually happens, it's going to depend on how good we've been able to program the systems and the guardrails are put in there and how clever these systems are at evading human controls. Already in controlled scenarios, AI has been told, okay, we're going to try and shut you down, but you need to be able to fool us and try and stay alive. So it's copied itself into different states. It's faked resetting itself, and it's faked. AI is faked that it's done what it's supposed to do, but in the background, it's done everything it could to stay alive. So that sounds like sci-fi nightmares coming true.
Just what do you think you're doing, Dave?
So, we're at this dangerous time. It may not be nuclear bombs that we launch. It may be like Skynet, as with the Matrix, got rid of humans, the virus that's causing all this cancer on the planet in terms of humans themselves being the virus, the Matrix scenario. I mean, in that scenario, they turned humans into batteries to stay alive because humans blacked out the sky. So it's been long predicted in sci-fi. What's actually going to happen? We're just going to have to live through it and hope that all these promises of ethics and integrity and building safe AI systems actually come true. Otherwise, it could be the end of the human race in a few years.
Hasta la vista, baby.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.